There are several reasons for the shift to running a wire conductor for an equipment grounding conductor, also known as EGC. Firstly, there's an increased reliance on electronic equipment. Electronic equipment is more sensitive to ground faults than older, less sophisticated equipment. A wire equipment grounding conductor provides a lower impedance path for ground fault currents. This lower impedance path helps to protect sensitive electronic equipment from damage caused by voltage surges and other ground fault phenomena. Secondly, there has been a decline in the quality of electrical work over the years. This decline, unfortunately, makes it more important to have a redundant equipment grounding conductor. A wire equipment grounding conductor provides a backup path for ground fault currents in case the raceway, which is the metallic conduit system, is damaged, improperly installed, or otherwise compromised. If the raceway is not properly connected or has become corroded, its ability to effectively carry fault current back to the source is significantly reduced. Thirdly, there's increased use of non-metallic raceways in modern electrical installations. Non-metallic raceways, such as PVC conduit, do not provide a reliable path for ground fault currents, as they are non-conductive by nature. Therefore, a wire equipment grounding conductor is absolutely necessary to ensure that there is a reliable path for ground fault currents in these raceway systems. Without a wire equipment grounding conductor, a ground fault in a non-metallic raceway system could create a dangerous situation, potentially leading to electrical shock or fire. The National Electrical Code, NEC, now requires a wire equipment grounding conductor for all new installations. This requirement reflects the understanding that a wire equipment grounding conductor provides an additional layer of safety and helps to ensure the reliable operation of electrical systems, especially in environments with sensitive electronic equipment. It's a good practice that helps to protect electronic equipment and ensures the safety of electrical installations by providing a dedicated, low-impedance path for fault current, regardless of the type or condition of the raceway system. The lower impedance path of a wire equipment grounding conductor compared to relying solely on the raceway system is crucial for the proper operation of overcurrent protection devices like circuit breakers and fuses. When a ground fault occurs, a sufficient amount of current must flow back to the source to quickly trip the breaker or blow the fuse. This rapid clearing of the fault minimizes the duration of the fault current, reducing the risk of damage to equipment and preventing electrical shock hazards. In older installations where the raceway system was the sole equipment grounding conductor, the impedance of the raceway path might have been high due to factors like loose connections, corrosion, or long conduit runs. This higher impedance could have limited the fault current, potentially delaying the activation of the overcurrent protection device and increasing the risk of hazards. The installation of a separate wire equipment grounding conductor ensures a low impedance path, regardless of the condition of the raceway, thereby improving the speed and reliability of fault clearing. Furthermore, the increasing complexity of electrical systems and the proliferation of sensitive electronic equipment have made it essential to have a robust grounding system. Modern electronic devices often rely on clean and stable grounding to function correctly and avoid malfunctions or damage. A dedicated wire equipment grounding conductor helps to minimize voltage differences between different points in the grounding system, reducing the risk of electrical noise and interference that can disrupt the operation of electronic equipment. By providing a consistent and reliable ground reference, a wire equipment grounding conductor contributes to the overall stability and performance of electronic systems. In addition to the benefits mentioned above, a wire equipment grounding conductor also offers advantages in terms of installation and maintenance. It is relatively easy to install a wire equipment grounding conductor alongside the circuit conductors, and it can be readily inspected and tested to verify its integrity. This allows electricians to ensure that the grounding system is properly installed and functioning as intended. In contrast, relying solely on the raceway system for grounding can be more challenging to verify, as it may require disassembling conduit connections and testing the continuity of the raceway path. Regular inspection and testing of the grounding system are essential to ensure its continued effectiveness over time. Corrosion, mechanical damage, or loose connections can compromise the integrity of the grounding path, potentially increasing the impedance and reducing its ability to carry fault current. By incorporating a wire equipment grounding conductor, electricians can easily monitor the grounding system and identify any potential problems before they lead to hazards. Moreover, the NEC mandates specific requirements for the size and installation of equipment grounding conductors to ensure their adequacy for carrying fault current. These requirements are based on the size of the circuit conductors and the potential fault current levels. By following these requirements, electricians can ensure that the equipment grounding conductor is capable of safely and effectively carrying fault current back to the source, minimizing the risk of equipment damage and electrical shock. In summary, the shift to running a wire equipment grounding conductor reflects a greater emphasis on electrical safety and the need to protect sensitive electronic equipment. While metallic raceways can provide a grounding path, a separate wire equipment grounding conductor offers several advantages, including lower impedance, redundancy, and ease of inspection. The NEC now requires a wire equipment grounding conductor for all new installations, underscoring the importance of this safety measure. By understanding the reasons behind this shift, electricians and other electrical professionals can ensure that electrical systems are properly grounded and protected, contributing to a safer and more reliable electrical environment. Moreover, the evolution of grounding practices also takes into account the increased use of isolated ground systems, particularly in environments with sensitive electronic equipment. An isolated ground system separates the grounding conductor for specific circuits or equipment from the building's main grounding system. This separation helps to minimize the flow of noise currents and interference into the sensitive equipment, improving its performance and reliability. The NEC recognizes and permits the use of isolated ground systems under certain conditions, provided that the grounding conductor is properly installed and connected to the main grounding system at a single point. The use of isolated ground systems further highlights the importance of a dedicated wire equipment grounding conductor, as it provides a clean and reliable path for fault current without introducing unwanted noise or interference. Additionally, advancements in grounding technology have led to the development of grounding electrodes and bonding techniques that enhance the effectiveness of grounding systems. Grounding electrodes, such as ground rods and ground plates, provide a direct connection to the earth, helping to dissipate fault current and stabilize voltage levels. Bonding techniques such as bonding jumpers and grounding bushings ensure that all metallic parts of the electrical system are electrically connected to the grounding system, creating a low impedance path for fault current. By combining these advanced grounding technologies with a dedicated wire equipment grounding conductor, electricians can create a comprehensive grounding system that provides superior protection against electrical hazards and ensures the reliable operation of electrical equipment. Furthermore, the increasing awareness of the potential hazards associated with improper grounding has led to more stringent enforcement of electrical codes and regulations. Electrical inspectors are now more vigilant in their inspections of grounding systems, ensuring that they comply with the NEC and other applicable standards. This increased scrutiny has further reinforced the importance of a dedicated wire equipment grounding conductor, as it provides a clear and verifiable means of demonstrating compliance with grounding requirements. In conclusion, the transition towards incorporating a wire equipment grounding conductor alongside metallic raceways represents a significant advancement in electrical safety practices. This evolution stems from the increasing prevalence of sensitive electronic equipment, concerns regarding workmanship quality, and the growing utilization of non-metallic raceways. By providing a redundant, low-impedance pathway for fault currents, a wire equipment grounding conductor ensures the swift and dependable operation of overcurrent protection devices, reduces the risk of equipment damage, and minimizes the potential for electrical shock hazards. The National Electrical Code's mandate for wire equipment grounding conductors in new installations reflects the unwavering commitment to prioritizing electrical safety and fostering a safer electrical environment for all. Furthermore, the integration of advanced grounding technologies and the heightened enforcement of electrical codes underscore the ongoing efforts to enhance the effectiveness of grounding systems and safeguard against electrical hazards.